Okay, I'm going to try to do a really super quick one-handed video. This will be a little shaky because I don't have my tripod, just on logarithmic form versus exponential form. So normally if we have something that's like 9 equals 3 squared, that is exponential form, and we rearrange it this way, this is what's called logarithmic form. And what I don't like about most videos that show this is they just show, well, you just rearrange everything. This basically says the log means we'll take some number and what is, for the base over here, what power do you raise the base to get to that number? So, 9, if I use the base 3, well, that's 3 squared. So this is, most places just tell you, well, this is the form. But what's actually happening here, which I want to show, is that it's really the inverse function. If I take the log of both sides here, okay, if I take the log of both sides, what actually happens there is I get a log over here, and I'm going to take a log 3 of both sides. There are different kinds of logs. If I take the log 3 of both sides, basically what that does, well, this side stays log 3 of 9, but this over here says, well, log 3 of 3 squared. Well, the answer to that question is what, 3 squared is 3 to what power? What's 2? So that just simplifies to 2. So that's actually why it turns into that form. And I'd just like for people to understand that this is not just a magical rearrangement. There's a reason for this. And most videos don't kind of explain what's going on there. Is you're actually taking the inverse of both sides there, and that's why it turns into that form. This kind of seems magical sometimes. It's like, oh, well, that's just the way you do it. And then I had this other thing come up in the background there. Hold on, let me erase this. Discard. Bring that back up again. Okay, so once again, that is, and you can just memorize where things go here. So 10,000 is 10 to the 4th, that's true. Well, I can rearrange that and say, well, in logarithmic form, that's log 10,000, so I'd take the log of that side, and then when I take the log of the other side, well, the answer is really just 4. And then the question is, well, why is there no 10 here? If we just say log, we imply that it's a 10 there. You can write the 10 there, but you don't need to. But usually if we say log, we mean log base 10, or sometimes when people say log, they mean natural log, but they'll typically say natural log. So once again, 2 to the 3rd is equal to 8. If I take the log of both sides, it doesn't matter what order I do this in. Notice we flip-flop the order here. If I take the log of 2 to the 3rd, log base 2 of 2 to the 3rd is just 3. And then log 2 of 8 on the other side is that. It's a different way to write it. And eventually we'll get to is something like this where I don't know an answer. One, I can reason it out if my base and my number that I'm doing are things I recognize. And then there's a way to do this in the calculator for ones I don't recognize. And that's where this becomes really important, is because there is a log function in our calculator, and there are a couple of tricks where you can find things where a log base 2 or log base 3, which are not familiar logs. So in this case, if I look at this form over here, which is probably more familiar to me, hopefully most of you will recognize, oh, that's 8 times 4, so that's 2 to the 3rd, that's to the 5th. So that should be a 5 for both those there. The answer there is x equals 5, because 2 to the 5th is 32. Both these are asking the same question. The next one, 3 to the 4th equals x. It's one way to ask the question. If I take the log of both sides, I got 4 equals 3 to what power? Well, actually, this is 3 to the 4th power. What number do I have? So in this case, my x is 81. And I got one more here, I think. X to the 3rd is 125. An equivalent way to write that, if I take the log of x of both sides, is this. And I don't know what that announcement was going to be. So it's saying, well, some number to the 3rd power is 125. And this one, hopefully you recognize, is also going to be 5. So you can memorize where these things go and just recognize, well, in this, the base will always go here. The number that you're shooting for always goes here. And the exponent on the base always goes on the other side. You can memorize that pattern, but I like for people to know why that pattern exists. Is literally you're taking the log of both sides, but the log, the base log of any base to that power is that power, and so that's why that works. Okay, hopefully that was somewhat helpful.